So here's the picture version. Here is our function, not yet constructed. There's t, and there is x of t. So what we know is that when t is equal to 0, our function value is 1. So that's x of 0 equal 1. We also know that x prime of t is given by 3t squared. So that means that the slope right at the origin will be 0 if I plug in t equals 0. So that means the function will look flat at the origin. And so we could continue drawing the function, and at every moment we can recalculate the slope and include that appropriately. But we can't do that in Excel because we have to do it at discrete times. So what we do instead is we say, okay, let's go for an interval delta t. And I'm going to call that t1. That's my first t value. So let's say that the slope is close to 0 through that entire interval of time, and let's just approximate the function by saying it is 0. So let's put the new value right there, and that's our approximation of the function. So that, how do we get that? Well, we took the x, so to get x at t1, we took x at t of 0, the initial time, and added to that the slope times the size of the time interval. So I'm going to write that as delta t times x prime at t0. Now in this case, x prime of t0 is just 0. So let's do another one. Because that ended up just being a 0 that we added. It didn't change anything. Now that we know we're at delta t, or t1, we know that the derivative at that point is given by 3t1 squared. So that means that when I plug it in, I'm going to get a small value here squared multiplied by 3. I get some small positive value. So my slope at that point is a small positive slope. And now I'm going to do the same thing going off to 2 times delta t, going to the second time interval that I'm keeping track of. And what I'll do then is pretend the slope is the same all the way until I get to 2 delta t, or to t2. How do I calculate what the increase is there? Well, I take advantage of the fact that I know the slope. So what I do is I say that x at t2 is equal to x at the previous time, but then I add to that whatever my run is here, my rise is. The run we know is delta t, so if we multiply delta t, which we know, by the slope at t1, we'll find out how much the function approximately rose in the meantime. And so this, in general, is our formula for calculating subsequent times. So x at tn plus 1 is equal to exactly the value at tn plus delta t times the slope at tn. When we go to the spreadsheet, keep in mind that we're talking about adding to the previous value and using the slope at the previous time. Okay? So keep in mind that as we do this, we're making this approximation that the slope is constant throughout this time interval. So if you make delta t too big and the slope changes dramatically through that interval, this approximation is not going to be very good. But if you choose a very small delta t, then this approximation will get better. And that's what we're going to have to do. So let's switch back to Excel and let's implement that formula that we just came up with. So we want to take the previous value and add to it delta t, which is in B8, multiplied by the slope at the previous time. So the slope at the current time that we're trying to find is this, but we want it at the previous time, so we add the previous x prime value in D2. And now when we copy that all the way down, you can see that we're getting closer, well, close to what we expect, which is 28. But that's not going to be good enough for web work because it likes to have a 0.01% relative accuracy, which means we have to go down 4 decimals and wait and make sure that this one is correct. So how do we do that? Well, we increase our number of intervals. So we divide up the interval from 0 to 3 into more intervals, which means that we have to include more time steps in order to get there. And now you can see that the value is a little bit better. So let's start keeping track of these. I'm going to put n here, 10, 20, and then our estimate of x of 3. And this will allow us to see how well we're doing in terms of the decimal point. So our first one was 24 and change. Now we've gone to 26.00875. And if I go higher again, 40, now I'm going to have to go off the screen when I hit 40, and I don't want to keep copying. So let's just copy once, way far down in the spreadsheet. And then we'll just have to find our t equal 3 value from this huge column, instead of spending a whole bunch of time copying and pasting. So let's go. Maybe this is enough. Keep in mind that for your numbers, for your problem in the web work assignment, 4 or 5 repetitions of what I'm doing here with increasing n should be enough, but I have a different problem with a different function, so it's not going to be quite the same. I may not have as much luck, but at least it demonstrates the principle. So now when we have n equal 40, we need to look for t equal 3. There it is, t equal 3, and now that value I'm going to copy, Control C, and paste. But if I just paste, I'm going to paste the formula. So instead of pasting the formula, I'm going to paste special, choose value, and now I'll just get the number instead of the formula placed in there. If you just hit Control V, then it'll paste the formula and it'll be referring to the wrong set of numbers. So that's exactly the value we want. If we increase n to 80, now let's look for the 3 value. Where is t equal 3? There it is. And now I'll copy that. And when I go here, now I can either go to the menu or I can hit, let's see, on my Mac it's Control Command V. And now I choose value. And I get 27.5. So you can see we're getting closer to 28, but we're not there yet. So we're not even at 1% accuracy yet, and we have to go to 0.01% accuracy. So let's say we go to 160. There's 3. And now paste in value, not the formula. And it's getting better, so let's see what happens when we double it again and go to 320. Searching for t equal 3, which should be, yeah, there it is. Copy, and now I'll do a special paste. And now for you, by this point, you should have fixed even further down in the decimals. I've only got a fixed answer down to two significant digits, but by this many iterations, you should be further down with your function. So I'll do one more and then leave it to you to finish it for your problem, which by this point, whoops, oh no, that's 0.03. So where is 3? Oh, gotta go further. How much further? There we go. Past 3. There it is. Oops. See that? Pasted a formula. And this formula refers to meaningless cells. So that's not what I wanted to do. I wanted to paste special and paste a value in. And now the number is the correct one, 27.9. So I'm getting closer to 28. This would still not be enough for web work, but my function is not as well behaved as yours ought to be. You should have really good accuracy already by the time you've done this 4 or 5 times. So that is antiderivatives numerically.